What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
Welcome to another episode of the Concrete Logic Podcast. Today I have Joe Shetterley with E5 with me, and we're going to talk about liquid fly ash. But before we get started, just to remind everyone how the podcast works, I ask you, if you want to support the podcast, to do three things. So the first thing is to share this episode or any of the episodes. We're over 100 episodes now. Share the episode with a coworker or colleague or someone out there that needs to be hit over the head with something. And then the second way is if you go to concretelogicpodcast.com, you can reach out to me a couple ways. One is there's a contact button or link. You click on that. That's like sending me an email. Or in the bottom right-hand corner, there's a little microphone. You click on that, and that's like leaving me a voicemail. And what I'm looking for are topic or guest suggestions for episodes, because that's what this podcast is all about. I do this podcast for you all who are listening. So please reach out and give me suggestions. And then the last way is if you want to, if you get some value, this podcast is based on a value for value model, which is basically saying I provide you the podcast. Folks like Joe come on and donate their time and share their knowledge with you. And if that is value to you, what I ask is that you give a value back. You click on the donate button that's on the home page, and you can give any amount, and any amount is appreciated. All right. I did it under 2 minutes. That must have been a good cup of coffee this morning. So, Joe, you were last on the episode or on the podcast, episode number 28, November 3rd, 2022. So almost 2 years ago.
Almost 2 years.
Yes, sir. So I appreciate you coming back on. And the first time we came in, you came on the show, I think we talked mostly about internal curing, and which was back then I was new to me. So I'm 2 years of following along and very interested in internal curing. But today I wanted to bring you on and talk about liquid fly ash technology. So if you could, I guess, start off, what's the difference between liquid fly ash and the fly ash that we all know and love? I don't know if we love it. We don't love it. I was just being sarcastic.
Liquid fly ash was branded the name to cause controversy.
Yeah.
Because this industry doesn't really like to sit around and have a conversation about things. So when I was on the bridge and we were putting this together, I thought, I'm going to name this liquid fly ash. And one of my consultants says, you can't do that. I said, well, yes, I can. Because if Liquid Nail can name their substance liquid nail, and it's not a nail, I can say liquid fly ash, even though I'm not liquid fly ash. It's a conversation piece, but it does have characteristics of traditional fly ash. And what I mean by characteristics, CH consumption, it has a high pozzolanic reaction. Those are characteristics of an SCM. So liquid fly ash is not fly ash. We've established that it doesn't have fly ash, but it's nanosilica particles in suspension, and it is suspended with different particle sizes, shapes, polarity, things like that to give it a function as a liquid SCM.
So same technology that we talked about before as the internal cure. So what's different about it versus the internal cure?
So the difference between internal cure and LFA is that internal cure has a narrow particle band of silica. So it is much narrow in size and shape, meaning it's more repeatable. And that allows for attraction to water, where liquid fly ash has a wider band of particle distribution, and it can fill into gaps smaller and bigger for those CH site for CH consumption.
CH and what's CH?
Calcium hydroxide.
Okay.
It reacts with the byproduct of the cement hydration.
Okay. And I was going to ask you. So that what is the problem we're trying to solve, Joe? Why you call it liquid fly ash? Why do we use fly ash? What's the problem we're trying to all solve here?
The problem I was solving first was I was on a bridge, and the ready mix supplier was not happy that day because he had 6 trucks rejected because of air issues. Well, they were using a F ash at the time, and it was just very unstable. Well, the owner of the ready mix company come by and says, "I am so sick of these SCMs," and he was just complaining about it. And I thought, that is an issue. 6 trucks go back's a lot of money. That's got to be dumped. Not only a lot of money, but it's 60 cubic yards that's going on the ground somewhere. Well, how's that good for the environment? It's not. So I'm like, well, we need our F ashes and our C ashes are not the same as they used to be when they came out. They're not as, the quality is not there anymore. So that was the one problem. Why I started going down that trail of liquid fly ash was to help the air issue. Second was finishers do not like to finish SCMs, whether it's fly ash, slag, because interior wise, it can delay the set, increase bleed rates. You can get differential drying. You can actually get spikes in air in an interior mix that sometimes makes you sticky and delaminate because of the properties that are in some of these SCMs are not as pure as they used to be. So those are the problems I'm solving by using a liquid pozzolan to help stabilize that and give back the matrix of the concrete that an SCM will give a good SCMs give a good structure, I should say, in a matrix of concrete, a denser, harder structure over time. And over time means after 28 days of that period. So liquid fly ash, I wanted to build to increase all those properties within the 28 days, but not give concrete finishers the problems that they would have finishing it. And then the owner benefits from all those internal benefits long term for his return on his investment. So those are all the problems I was trying to solve with liquid fly ash. I see it every day on bridge pours. When people start to use the LFA and internal cure mix together on a bridge, it's like a light bulb goes over their head and they're like, where's this been? Well, because they have fought so many years of using extremely dry mixes with a unreliable SCM, and it's sticky, it's fighting it, the air's all over the place. You got engineers that are aggravated because they're chasing air. It's 8% on one truck, goes to 5% on another, and then they're dosing it back and forth to where LFA stabilizes all that. They're not chasing the air because it's more pure. It's a more pure form of a pozzolan versus an unreliable purity. That's all the problems I was solving.
Gotcha. So we were using fly ash or slag, those SCMs, to offset the amount of cement that we're using because of the global warming potential or whatever metrics you're we're all being served right now. Anyways, so are you saying, so if something calls for a certain amount of fly ash or slag, are you completely replacing that, so no longer having fly ash or slag in the mix?
I would say at the beginning of the launch of LFA, I made a couple mistakes. As concrete finishers, we're very brazen. We have we're not easy to adopt to changes, um, and we seem to know everything sometimes as concrete finishers, and we're hard headed. And I basically stepped out there and said, "No, I can replace it all." Well, that was my first mistake by making that claim. Second was pushing it forward in that manner, and I had to correct some of them. And what I mean by correcting them is certain cement do certain things, and not all cements are cements. And the cements, the way they're built, have another reaction with the SCMs. I didn't have that knowledge. I just seen the LFA work from 2 or 3 different cements, and it was able to reduce that cement and was able to go on. Then when I stepped out and started using a different cement from a different geographical area, it all went away. Well, then I had to start incorporating back some of the SCM back in with combination of LFA, and everything would come back into compliance because the cement was missing something that the other SCM that was powderized gave back to the cement, and then mine just made everything come back into effect more efficient. So instead of a 30% F ash, they could reduce it down to 10% and then use me at 8 ounces per hundredweight. Now, what that did was pick all that risk, that extra 20% of fly ash, bring it down to 10%. I lowered all the problematic issues with the F ash. We still had stabilized air. We still had consistent set times. We had consistent bleed rates, and we had consistent set times. So it's like, all right, this is a SCM enhancer or replacer. It can do either one, but it's really dependent on your cement.
Yeah. So you gotta do testing and
Yes,
yeah.
and what I do is when a producer starts to work with me, I say send me 5 gallon bucket of your cement. I go to my lab, and Dr. Nilu goes in and she does her mortar cube samples, and we start taking all the problems out and figure out where they're at, so that they don't have to do that guesswork. So I've got buckets of cement all over the lab. I've probably got 15 different ones. And we know now, we got a protocol. We come in, hit the 1-day break, 3-day, 7. We already know what it's going to do within a week. And then that producer can like, all right, this is where I'd start. And then, within his week, a 7-day testing, he already knows where to go.
In that 5-gallon bucket, is it just the cement, or if there's a fly ash or a slag mix, do they send that to you too? Or
They'll send me their fly ashes or their slags with it. As slag is going up in cost, it's just as much as cement. So it's kind of like, why? I mean, if it causes these few little issues in the finishing process, why even go to it? Just go with the cement, roll with an LFA, and then all your finishing and all your workability and all your sustainability, all that comes into the same play, but the problems are reduced in the field at the finishing level, which is what we're always arguing about, is the problems at the finishing level.
Yeah. Finishing and breaks and
yes,
cracking.
he put too much water in. Oh, he didn't do this. And
yeah, but yeah, definitely finishes the look seems to be a topic for me recently. Is someone wasn't happy with the finish quality. So yeah, it's got a lot to do with it. Even though you can meet all the specs, but the look was more the concern.
Yeah, you get that aesthetic conversation going on. Well, I mean, it meets all the criteria: strength, flatness, all the stuff's met. Then I can't help this the way it turned out. Material's material,
right?
I mean, I was blessed enough and raised in an era where I seen fly ash come in, the real stuff in 1987, 88, 89, 90, 93. I seen the F ashes and C ash come in. Well, instantly when that stuff come in, it was already, we seen bleed rates where we were taking garden hoses and dragging the water off of the slab. It's like, where'd this come from? It's like, but then they claim, oh, it helps reduce bleed water. Well, you might want to come out here because it's not. Well, if it's not reactive, it doesn't have reactivity, then, and you've replaced that with cement that has reactivity, then yeah, there's a problem coming up somewhere.
Right.
Well, bleed rates where I seen it come in firsthand in my finishing days in the late 80s, early 90s. So then my dad put a stop to it and said there will be no fly ash mixes in our mix designs at all whatsoever. Even engineers would call for them. We would run a submittal and say, no, we want a straight bag mix and we are not dealing with this. Because overtime, people staying late on jobs because of set times. Same thing, sending trucks back because of air. That causes contractors money. I wanted to build a liquid pozzolan that would satisfy the engineer and all the requirements that pozzolan was going to give him, but yet took care of the finisher in the field. And that's where LFA,
Yeah.
that's why it was built.
Yeah, that's when you're talking about when the fly ashes came on saying it really sounds like what's going on right now with type 1L.
Absolutely. And I got two specific projects I've worked on in the last 2 months where the engineer had spec 25% fly ash, and they go to do, and they even had E5 internal cure in the spec. Well, we did the first pour and we go down there and there was this massive random of cracking. It's like, oh my gosh, what happened? Well, we start going back. Well, to our earlier conversation, water demand wasn't met. It was too dry. Second, the internal cure did its job, but what was happening, the water wasn't distributed enough in that mix. The fly ash wasn't able to wet out, so it robbed more water. And then the cement wasn't wetting out because of the finenesses of it. So they had this lack of water going on. It's like, all right, what do we do? So they asked me, and I said, this is my personal opinion. Do a side by side. Do that mix again on a 20 by 20, but then I want you to replace all your fly ash with liquid fly ash. And let's see what happens. Well, they did it. They had the same issues on that slab with the traditional fly ash. They used the LFA in combination with the IC. All the cracks were gone. They ended up finishing the whole job with it. No more cracks. So there's this dynamic between 1L fineness and the finenesses of the F ash and the other components of the F ash that don't like to work with each other. What that is right now, there's research ongoing what that is, and I hope to know that in the next 9 months to 12 months. But there's a weird water exchange between those two products together that's helping cracking. What's the word I'm looking for? It's producing cracking, more or less. And I don't know if it's because of the delay sets, because 1Ls can be a little bit slow in delay. And you got this weird dynamic going on. But then another one was a parking garage. We had a parking garage, same thing. Had 30% F-ash in, had internal cure spec. They sent me a picture before they had it finished. It hadn't even finished. It looked like someone dropped a metal ball in the middle of the slab and it just cracked everywhere.
Oh,
all over. And I'm like, oh my gosh, what happened? Someone fall? Well, we did an investigation. They said, what's the recommendation? I said, well, but I'm going to promote it. I'm going to say I get rid of the fly ash. I said, I think it's an issue. Too many fines, not enough way to balance water out. Well, they went to the LFA mix, what we call the Indiana DOT mix, LFA internal cure, and they ended up finishing that whole parking garage with that mix. No more cracking from that point on. So the SCMs we have today are just not reliable as they used to be. And it goes back to water. LFA, internal cure, either product helps water move. One's more pozzolanic reaction. The other one's a high control of water. But if we don't have control of the water within the mix with these thirsty SCMs and the thirsty 1L, you're just beating your head against the wall with traditional ways of doing things.
Yeah, that seems to be the common denominator there is the water, how the water's behaving between the two. I would say both are fairly new materials, the new fly ash and the new cement, and we're just moving right along with the same water cement ratios as you and I were talking before we hit
Right.
record, over 100 years now. But we have
Right.
totally new binder material.
Yeah, the binder materials are thirstier, finer. Um, some of them are not as reactive as they used to be. And when we've already incorporated a limestone that is not as reactive of the clinker we replaced, I mean, you just increased your risk of cracking. Because we do want that concrete to react at a rate that it overcomes the strain that we've put it in. And if you don't have enough water for these products and they rob your water, well, you've created a internal autogenous cracking situation, and then it shows up external. Um, One of the big things I try to tell people to grab their heads around it. Think of concrete no different than the human body. Okay. The human body, if it has something going on internally, it eventually shows up where? External. It's just the way it works. Concrete's no different. If the external problems are there and you can't see them and there's not enough water to help, it shows up where? External.
Uh-huh.
And what do we go do? We try to fix the external real quick with something external. Well, let's go put a topical on. Let's go put a densifier on. Well, let's do this. Let's do that. And I'm going, all your problems internal. So if you start with internally controlling the problem, which I'm going to say it 100 times, it's all about curing. And if you can get that first initial step done by controlling the water internally, for that to develop correctly, I don't care what you do. It's all going in the basket, and we're all arguing about it in months. You got to start it off there. Same way with your body. Give it some water, give it the hydration, and externally, your skin glows. It's more flexible. You look healthier. Why? Because you fixed it internally.
Right.
And then your external shines. I look at concrete no different. Same thing.
There's a supplement line there. I'm
yes.
hearing.
85.
And
no joke. GNC does sell. I don't work for them, by the way, but GNC does sell a colloidal silica pill.
Do they really?
Yes, they do.
I think I've taken everything else under the moon. I haven't done that one yet.
Yep, they do sell it.
Huh. Somebody beat us to it, Joe.
Oh, yes, sir.
Yeah. So there's, again, going back to what you're saying, we only treat the top 1 inch of concrete, and although there's another 6, maybe 9 inches of concrete that we're not treating, and it all rises to the surface. Those are all great points. So yeah, I really think, just listening to you and our conversation here, it's really about balancing it seems like balancing the water.
Absolutely. And that's the one thing, Seth, think about it, in your career too. I mean, everything's been driven off low water cement ratios. Get the strength up. Well, that's great. I'm glad you got strength. But at the rate our concrete's failing right now, that's not the right data point we should be looking at.
Mm-hmm.
What we should be looking at is what's going on internally so it develops external. And strength's not the answer. The more strength doesn't mean, oh my God, I got great concrete. I've seen concrete 10,000 PSI fall apart faster than I've seen sidewalks poured with 3,000 PSI.
Yeah.
Well, what's the difference? Well, first of all, we'll go back to my Bible, concrete manual.
Yeah.
Everything started with a wet cure back then, and everything was controlled at decent water cement ratios. And at this time frame, this was written in 1963, Duff Abrams had only been around, that law was about 50, 60 years old.
Mm-hmm.
So the finesses of the cement were still somewhat the same as what he created that law with. And then now we fast forward way up here, we're 120 some years away, and our finesses of our cement are way up here now, 100% different than what he was. And yet we're still trying to fight it with the same water. The math don't work.
Right.
Even with the fly ashes and the slags, the metacalins, the silica fumes, the pumice, all those materials are ultra fine, ultra aggressive, and want water. They're very thirsty material. Well, with that thirsty material, if you're using the same water cement ratio and you incorporate a percentage of those in, well, you just went from a 4.0 to a 3.6. You just put your concrete into a cracking potential because you didn't give it enough water in the first place. You have to understand the water demand of the product and be able to say water demands X. I'm putting an extra 5 gallons in, but it's not going to count against my water cement ratio. That's where the industry's got to be okay with accepting something like that. But I don't know who's going to be that champion to stand up there and prove that that's what needs to be done. Because I'm a concrete finisher from Indianapolis, Indiana. I'm an expert at nanotechnology, and I know what that piece does, but I'm not an expert in the water cement ratio game and how that needs to be proven out. I've got a good concept of it. I know how it works with nanoparticles, but outside of nanoparticles, that's a much bigger endeavor for someone.
Yeah, and I don't necessarily know if it's just the water cement ratio. Again, it's trying to figure out if like the water's balanced across that 9 or 10 yards you're getting into the truck. So someone's got to come up with a way to measure that the water is dispersed equally across the board, because when you put all this stuff that we're putting in concrete, to say nicely, the stuff that we're putting in cement and the fly ash and what's making up our concrete now is what I'm thinking, and what I'm hearing from you is it sounds like the water's not getting to all parts of that load. And so you're going to have a truck that maybe the first half is okay, but the back half of that truck is garbage. And then you're putting it down on the floor. So you got a section that looks fantastic, finishes great, and then the other section you got like, what do they call that? They got the pock face looking.
The crazy.
Yeah, that, or the where it's not delaminating, but it kind of looks like the surface popped off of it.
Oh, blisters.
Yeah,
They'll do little blisters, little pops.
Yeah. Seeing that.
Well, when I was out in the field, when I'm always out in the field and I'm watching things, you can always tell when they haven't really properly done their aggregate moistures, or they're not watching them close enough. The first, take 100-yard pour. Well, the first 3 or 4 or 5 trucks come in, they're ultra dry. Well, what's everybody do on job site? Put water in it, trying to get to that 5-6 inch slump, whatever they're trying to achieve. Well, you just broke the hydration chain when you added that water to it. Well, strength goes down. Got my 5-inch slump, but you should have had it done correctly at the plant, not on the job site. I always tried to make sure when my concrete truck was entering my job sites, if I wanted a 6-inch slump on the site, I always worked with my producer, say, look, you can batch it at a 7. I don't care what you batch it at. I want it batched wetter, so when it drives and it's starting to hydrate, all that material's using up the water where it needs. By the time it got to me, it was a 6-inch slump. So my guys never added water to disturb the hydration process. Now, did I do that my whole career? Heck no. When did I learn to do that? As soon as I started dealing with nanoparticles, started to understand hydration, how to control water, how those things I was doing was wrong, but no one taught me. I don't even think the industry teaches anybody that it's about the hydration and the continuum of the hydration and not disrupting that gives you the ultimate concrete durability, sustainability, and strength. Just don't disrupt it once it's started. Once that water hits that truck, it is started.
Yeah.
Leave it, you're done. But then we disrupt it somewhere. Where do we disrupt it? Job site, on the way to temper the load. Why? Because we don't understand that the materials we're dealing with need a certain amount of water, and it's robbing our mixed water to go, and it's robbing our mixed water, taking away from our hydration, and then we add more water because we didn't factor in what those materials need or the water demand of those materials. So we're actually, as smart as people we have in the entire industry, I'm still complexed of all the problems we still have. There are some smart individuals in this concrete industry, but yet we still got the same problems we've been dealing with for 100 years. Why?
Because they all have their individual goals. They don't line across the board. I mean, you could take that across society as a whole. But anyway, when you're talking like this too, is are you in your mixes? Are you still using high range water reducer?
That's reduced significantly.
Yeah.
Because when I say I want a 4-5 water cement ratio, I want a 4-5. I don't want my producer holding back a couple gallons so he can sell me a high range when he didn't give me all my water. Give me my water.
Uh-huh. I
want you to give me all the water that mix is supposed to have. If it says 31 gallons of water, don't give me 30 because you didn't check your moistures.
Mm-hmm.
I want 31 gallons, and then you can adjust that with your high range or your mid range. Okay, then I always had less chemical because I'm a concrete finisher, not a chemical finisher. I want concrete, and the less chemical I can put in it, the more success I had. Chemicals is killing our industry. I'm straight up. It's killing our industry, and that's why we're arguing all the time. And we've got to get back to a more holistic look of materials versus the traditional mindset of chemical fix this. Chemicals are not going to fix it. Water and water control will fix our mixes.
Yeah.
That's what's going to fix it. Nanoparticles, no matter if it's E5 or it's titanium dioxide or graphene, anything in the nano world is going to start helping us better because of how fine our materials are getting and how water demanding our materials are getting. They will help. And that is the future. Nanoparticles are the future. I've said this many times. I said traditional admixtures, I believe before I die, will almost be obsolete.
I believe it. I mean, I think, because the cement's not going to go back. So
that's right.
you gotta fix that problem.
And what's coming up is the nano world,
or smaller.
Oh yes, or smaller.
And we'll leave it at that. We'll leave them at that. We'll get them smaller. So things are going to get smaller than nanos. So we'll leave the episode at that. Joe, if folks want to reach out to you, learn more about what you're doing, what's the best way?
Best way is go to our website, www.e5nanosilica.com, or you can reach my cell phone, 317-440-1157.
Cool. I appreciate that. Thanks you for coming back on the show. And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. And This ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood,